In this video, I'll be covering problems 2, 3, 4, and 5 for Unit Test 2 review on function operations, composition, and inverse functions. So for problem 2, you are asked to determine if these two functions are inverses, and I ask you to verify algebraically using compositions. So keep in mind that that means we're going to do f composed with g and see if it equals g composed with f, which, if it comes out to equal x, will mean that these two functions are inverses. So I have these two functions written here, and the first thing I'm going to find is f composed with g. So what that means is I'm going to take all of g and plug it into f. So I'm going to take all this g stuff and plug it here to f. So that means I'm keeping the 5 and the plus 7, but in its place I'm going to put 1/5 x minus 7/5. Your job at this point is to distribute and simplify it. So that would give us 5 over 5x minus 35 over 5. I can recognize that 5 over 5 is going to give us 1x, and negative 35 divided by 5 is 7. So I'm left with x minus 7 plus 7, and negative 7 plus 7 is 0, so I just get x. So that's good news. If I get x, I'm going to proceed and find g composed with f. So that means I'm going to take f, which is the 5x plus 7 now, and plug it in to g of x. So I'm going to write the function g, but leaving out the x, knowing I'm going to put a quantity in its place and put the minus 7/5 here on the outside. So I'm copying that function, but I'm taking out the x and I'm replacing it with 5x plus 7. So next I'll distribute the 1/5. Remember, we can put this over 1 to make it a little more helpful. You just multiply numerators together and multiply denominators. So 1 times 5x, that would give us 5x divided by 5 times 1 is 5, plus 1 times 7 is 7 over 5 times 1 is 5. And I bring down the minus 7/5. Well, hopefully we recognize that 5 divided by 5 equals 1, so that's going to cancel out, leaving our x. But then 7/5 minus 7/5 is 0. So that means we get x. So that's not enough. Now you have to write the statement to demonstrate that you understand that they're inverses. So we write down that f composed with g is equal to g composed with f, which equals x. We got x for both of them, comma. Therefore, we know that f of x and g of x are inverses. So this statement is required. Alright, for problem 3, you're asked to find the inverse of each function algebraically and verify graphically when you're finished. So we don't have to graph them for the test, not these specifically, but we are going to put them in our calculator to see if they're symmetric about y equals x. So for part A, remember we're going to follow the steps as outlined in your notes. The first step is to replace your function notation with y. Then switch x and y and solve for y. So the first step would be to subtract 5 from both sides. Then divide by negative 6. That cancels out because it equals 1. And we're left with negative 1 over 6. So there's an understood 1 there. So negative 1/6. A negative divided by negative makes this positive 5/6. Now what I'm going to do is I could put y, but then I'd have to change it, because if my function is h of x, I need to write my final function as h inverse of x. So h inverse of x equals negative 1/6. Oh goodness, I forgot my x. Negative 1/6 x plus 5/6. For part B, this is a square root function. So we've got negative 3 times the square root of the quantity x minus 8. Subtract 5. So likewise, we're going to follow those same steps. Y equals If you want to go ahead and skip to step 2 and switch those, that's perfectly fine. And our job is to get y by itself. So we want to add 5 to both sides. Divide both sides by the coefficient -3. And do not simplify this. It's perfectly fine to just leave it. And that leaves us with the square root of y minus 8. At this point, we need to recognize that to get rid of a radical, we need to square both sides. And that does mean we will square the entirety. However, I'm not asking you to simplify it. So we'll leave this as the quantity x plus 5 divided by -3, all squared, is equal to y minus 8, because this square canceled the square root. Our last step is to add 8 to both sides. So when I write it as my final answer, I'm going to say g inverse of x is equal to the quantity x plus 5 over -3, all squared, add 8. Okay? Next, for part C, we have z of x is equal to the quantity x minus 4 squared, add 6. Our first step, replace z of x with y. Switch x and y. And solve for y. So I first need to subtract 6 from both sides. And this is the kicker here, the big important thing we have to remember. When we graph a parabola, the inverse is going to be a parabola turned on its side. So we have to remember that that's a square root function, but it's the positive and the negative. So when I take the square root of both sides, I need to put plus or minus the square root of x minus 6. That's very important. Equals y subtract 4. Last step would be to add 4 to both sides, but be cautious. Do not add the 4 to the -6 here. Simply rewrite it as y inverse, because it actually does not pass the vertical line test. We can't write it as a function. Y inverse equals plus or minus the square root of the quantity x minus 6 with plus 4 on the outside. Okay? That takes care of problem 3. Now on to problem 4. If you look back in your notes, guys, we did this. There was another problem very similar. So look back in your composition books and you'll find the example that we did with this one. It says to rent a car from the airport, the car company is going to charge you a flat rate of $25 as the initial fee and an additional 2 hours for every hour you keep the car. For part A, you are asked to write an equation for the cost of renting the car. So we want a cost equation. So cost equals in terms of the length you keep the car. So think about what our cost is. It says here they're going to charge a flat rate of $25. So they're going to charge you $25. And, so that's add, an additional $2 per every hour you keep the car. So that would be 2H for hours. So we're done with part A. That's it. Cost equals 25 plus 2H. Part B, when you get the bill, you see that it costs you a total of $39. How long did you drive the car? So since $39 is our cost, we should substitute that for C. So 39 equals 25 plus 2H. If it's asking how long, that's how long in hours. So how many hours? So our job is to solve for H. This is a simple two-step equation where we first undo any addition or subtraction. 39 minus 25 is 14. If we divide both sides by 2, we get 7 hours. 14 divided by 2 is 7. Next, part 5 says, describe 3 different ways of determining if two functions are inverses. And I recommend you make a bulleted list here. If you think back to the very beginning of when I taught you about inverse functions, we talked about the fact that the domain and range are switched, or the x and y's. So to determine if two functions are inverse, we could graph it in our calculator and check the table. So I'm going to put up here that if you check the table of ordered pairs, the domain and range, I'll put domain, which are your x's, and range, your y's, are switched. So check your table of ordered pairs, the domain and the range should be switched. The other is when you graph them, you should see symmetry. So the graphs should be symmetric about y equals x. So you simply need to memorize these, but we've talked about them over and over and over in class. And the lastly is the algebraic method, which is to determine if f composed with g is equal to g composed with f, which equals x. And those are your 3 different ways to determine if 2 functions are inverse. In the last video, I'll do 6, 7, and 8.